During this class, we'll be talking about Git. So the first important question to ask is, what is Git? Git is a method for version control. So kind of an indirect first question is, what is version control and why should I use it? I'm sure a lot of you may have come across situations like this. This is kind of a common cartoon which is shown when people are interacting with Git for the first time. You know, I've certainly run into situations like this myself when I was, say, editing papers on my Microsoft Word. You know, you get to some state of the document which you think is final. This in particular as a graduate student. So the graduate student, say, gives it to his advisor, who of course marks it all up in red ink. You go back to your computer and you try and revise it again, but you kind of still want to save the original version. So you start saving subsequent versions with what you hope are kind of indicative names of what the revisions are. More comments are made, more revisions are made. Eventually you get into something which is indecipherable for the file name and you can't really remember what revisions you made and past histories of the document. And this cartoon just makes fun of the fact that, you know, it gets very out of hand. So there are kind of a couple ways to try and track the changes or keep track of the history of the versions that you have for the document. Here you have track changes. Microsoft Word offers track changes. There are also, in Google Docs, say you can track the version history of a document. You can see who made particular changes to the document. But really it can be very useful when you have, say, a document like this, or it's become very prevalent in software development, to be able to keep track of the history of the document or of, say, a code base that you're developing without necessarily having to keep an entire history around inside of the folder that you're working with. So Git is an open source distributed version control system. We'll break down what this means. The first part is a version control system. So Git will store all of the content so you can keep track of the changes that you're making to your documents. This here is meant to be kind of a sequence of changes that are being made to documents. So say you have your original set of files that you're working with for your code base. Make changes here to 2 of your files. Then somebody else in tandem, say, is also working on the code base. So they make a couple changes to a different file. You can merge the changes into kind of a more complete merged set of files, but code development continues and you might add and subtract files and make changes in a variety of different places. Somehow you want to coordinate the effort of all of the developers or all of the authors of whatever documents it is that you're working with. And a version control system can help you keep track of the history of these changes. The distributed part of this definition has to do with whether the system is distributed or centralized. So when version control systems kind of started to come more prevalently on the scene, centralized version control systems were used where you had a central server that maintained kind of the central version of the repository. And the repository is what's keeping track of all of the files and the history of all of the updates that have been made. So anybody who wanted to work with the repository, they would check out a copy from the centralized server. They'd work on it and then they'd commit changes back to the repository. So by committing, it just means that any changes that they made are made more permanent into this centralized repository of information that was being stored. For distributed version control, everybody who's working on the repository has their own in a sense of copy. They have their own version of the repository. So everybody who's working on this particular repository, say with Git, which is a distributed version control, anytime you're working on the repository, you have access to everything that's necessary to reconstitute the repository, say, that's sitting on a common copy on the server that everybody accesses. So if anything happens to the server, no information is lost because anybody who has the repository has all of the information that's necessary for keeping track of the history of the changes and all of the files that are in it. And then we have the open source part. So Git is an open source software project. It's released under the new public license, and the code itself for Git is available via GitHub, and the changes are tracked with Git. So you can access the software code base for Git on GitHub. All right, so that's kind of a very brief introduction. Now we're going to get into an initial setup, kind of the initial things that you have to think about when you're interacting with Git. So kind of the first things first, I'm going to get us set up in our environments. You don't necessarily have to interact with anything it is that I'm saying, but if you want to, I'll make sure that I kind of allow some time for you to interact with what it is that I'm talking about. So I'm going to flip back and forth between different browser tabs. For those of you who want to work on your own computer, you should open up a terminal at the moment. For those of you who are interacting with Jupyter, the Jupyter Hub, hopefully you've been able to log in successfully to the hub. It will land you on a page that looks like this. So this is the default Jupyter environment. And I'm going to interact with Jupyter Lab because Jupyter Lab has kind of a nice little user interface, which will make it more convenient for me to show you the files that it is that I'm working with. So to go from this page to Jupyter Lab, simply go up to your browser tab, highlight the tree, and replace tree with lab, and then hit enter. And that will take you over to Jupyter Lab. So Jupyter Lab is starting up with the spinning windows. In all likelihood, you might get set on something that has a white background. This is kind of highly dependent on how you want to work, but since I'll be looking at the screen a lot, I've changed it to black or to darker colors. So you can change this by coming up to settings, going to Jupyter Lab theme and selecting Jupyter Lab dark instead of Jupyter Lab light. Jupyter Lab light has the white background with dark text. Jupyter Lab dark has the dark background with white text. So that's what I'll be working on. You can resize the browser or these tabs by moving your mouse over the boundary and dragging. And then the first thing I'm going to do is I'm going to make a new folder that I have files in. So that I'm going to make a new file folder with this. I'm going to enter in the name first demo. And then I'm going to double click on first demo so I'm inside of that folder. So apologies to those of you who are working on your computer. This is just some basic setup to get us started. Then here in the launcher, I'm going to come down and I'm going to click on terminal. And that's going to open up a terminal. And then as one final thing, right now it's showing you, this is my username on the hub, which has to do with the email address that I log in with. This is kind of too long for me to show during the exercises. So I'm going to change that. PS1 is kind of how if you set a different value for PS1, you're going to change what this prefix is. So I'm going to change it just to the name of the directory. And then the $ for the prompt, and then a space. So I have room between the prompt and what it is I'm typing. All right, so now we're set up. So the first thing probably to mention is how do we set up a Git repository? And we can set up a Git repository simply with the word Git and space init. Git init will initialize an empty Git repository in the directory that I'm sitting in. So at the moment, I've done something incorrect, which is that I've initialized the repository in the home directory that I'm sitting in. So maybe this is a good example to show you where Git stores its information. So if I list -al will list all of the files, including the hidden files in the hidden directories. So what I do when I initialize the Git repository, the information for the Git repository is stored in this folder called .git. .git then will store all of the kind of the Git database for maintaining the files and the history of the files that we're interacting with. I've initialized this Git repository in a place where I don't want things necessarily to be all version controlled, because I might have folders in this which are themselves Git repositories. So you don't necessarily want to have Git repositories within Git repositories or nested Git repositories, because then one Git repository will try and track the changes of another Git repository, and you kind of get into this feedback loop of tracking changes. So I don't want my home directory to be a Git repository. I'm going to delete the Git repository by removing this .git folder. The -r is for the directory and the F is for force. So this then removes the Git directory. And what I really want to be in is the folder that I've created for my Git repository, which I've called first-demo. All right, so now that I'm actually in the right directory, now I'm going to initialize my repository, and it tells me so it's created the Git repository in this first demo directory, and it tells me it's created this repository with the information in the .git folder. The other thing that's necessary at the beginning to set up is information that Git can keep track of as far as who's making the changes. So Git is very widely used because it invites collaborative efforts for editing documents. But in order for collaboration to be effective, you have to keep track of who it is that's making the changes. So Git keeps track of some configuration. If you type git config and then --list, I'm not sure what it will output for you, but it outputs this for me, and this is basic. These are basic configuration variables that I currently have set up. In all likelihood, if you're coming at this for the first time, you won't have the email and the name. And you'll want to set up the email and the name in order for your changes to be tracked successfully. So you can, let me come back up to the top. And I'll switch back over to my slides here. So I've mentioned in the slides Git commands. Anything that you write as a command at the text line is Git, verb, and options. So for example, with config is the verb, and then I have options after the verb. Git always comes first. To set up your username and user email, you would enter a command like this. Git config, and the --global tells you that this is applied across all repositories that you have on the system that you're interacting with. So the system I'm interacting with here is the local Jupyter user environment that I'm interacting with. And then user.name is the name of the configuration variable, and the information between quotes is the value for the variable. So if I want to set up my username, git config -- global. And then username, I can say, I'll just change this so it changes. And then I want to change I want to add the information for my email as well. If you've signed up with GitHub, this is just a side note, if you've signed up with GitHub and you want the kind of the changes that you're making here to be tracked to the same account that you have on GitHub, you want the username to be the same as the one that you've registered for with GitHub. And I mentioned git config -- list will show you the current configuration variables that you have. So if I execute that again, you can see, whereas my previous name was, I think, just Ben Winchen, now it's Benjamin John Winchen. And kind of rounding out our setup, we will be interacting with GitHub along the class. So the email address set with config should be the same as the email used for GitHub. If you have any concerns about email privacy, you can use a private email address with GitHub, and then you'll want to use the same email address for the user.email configuration variable that you set. Another technical detail is that interacting with the line endings on different systems can sometimes cause some confusion issues. If you're worried about line endings, you will want to pay attention to the core.autocrlf variable. Hopefully we won't run into any of that in this course, but this is just to mention it for you. And then if you have any preference as far as editors, the text editor that's used will be used for you to document the changes as you're making them. So core.editor is a way to set a configuration variable for a default editor that you want to use. We won't use this too much, but I mentioned this here for completeness. And then just in case you need help, always remember, if you forget a git command, you can use git -- help to list common commands. Or if you want help for a particular command, you can type git, the command name, and then -h for a short version. -- help will get you more of a manual-like documentation, or git help and then the command name. For those of you who are interacting with JupyterHub, JupyterHub has a kind of a reduced Linux environment for you to interact with, so it doesn't have a complete set of man pages for the documentation. But certainly if you're interacting with this on your own computer, you should have documentation for the help. So for example, if I want help about configuration, config -h will give me some of the options that are available with the config for Git. All right, so now we're set up. I hope everybody is set up to interact with your own system if you want to. And now we'll dive into interacting with Git and with the repository. So a Git repository is a virtual storage of your project. And it allows you to save versions of your code or versions of your projects, documents or files, which you can access as needed, and you can track the history. We already talked about making a repository with git init. The git init is used to initialize the Git repository. You can use git name and then the name of a directory if you want to make a directory called dir name in this case and initialize the repository inside of it. And you can run git init in subdirectories, but as I mentioned, having nested Git repositories can, in some cases, cause trouble down the road. And I also mentioned that Git will store information about the repository in this hidden directory called .git. So there are some basic methods that are important to learn first when we're learning Git. When we're thinking about keeping track of changes, we want to record what the changes are, the say that we've made to files. We want to be able to check the status, say to check the status of what changes have been made and what changes have actually been stored inside of the repository. We want to document the changes that are being made, and in some cases, we want to ignore changes. So say that you're working on a large software project and you want to ignore all of the object files which are generated when you compile code. You might not want to keep track of all of the object files. Maybe it's just a waste of space and there's no reason to save them or to save them in a change state. So you can specify that you want to ignore changes. And thinking about Git, I like this type of conceptual model. So Git is like a desk. And there are various states to the documents that you're working on. When you're just editing files, say inside of a certain directory, or in this case, typing into files on the computer, that's your working space. So that's one important space inside of your interaction with the Git repository. When you've gotten to a certain stage of completeness with a document on your computer, you might print it out and start compiling, say, notebooks of the documents that you're working with. So in this case, you move your document from a working space to a staging area. And the staging area isn't necessarily a final version of the document history, but it is some place where you've stored versions that you're thinking about committing into a more permanent place. Say you're making a chapter of a book and you're storing the chapter of a book inside of a folder. At some point, you'll get to a certain stage of completeness. Say you finish the chapter, and you have all the pages compiled together and you want to actually store them inside of the repository. So in that case, say you'll put the folder or binder into a desk drawer. And in this case, the desk drawer is considered the repository. So the repository is where you maintain a more final state of the changes that you've made. Staging area is intermediate, and the working space is the editing area. So we're going to go through putting files in all of these different areas. The first thing that we'll want to do is just make a file that we can add to our repository. And then we add files from the working area to the staging area by saying git and add, and then the files that we want to move into the staging area. So I'm going to edit a file. I'm going to, so I'll just create a file with VI. The Google Slides are not available for you to view on your own computers at the moment, but I will make them available at the end of the class. So I'm going to call this chapter 1. And you're welcome to edit the file in any text editor that you want. I'm going to say, and as well as to add any text that you want. I'm just going to say, I'm going to pretend that I'm an author and I'm writing the story. So I'm going to write the first sentence of my massively great novel, Once Upon a Time. And we'll keep this relatively simple so that the files are not complex and it's easier for us to concentrate on what it is that Git's doing. So here, I've created a sentence inside of my file and I saved the file. I'm going to do something a little snazzy here with JupyterHub, so I'm going to separate the file window so you can see this is the file I just edited This is the terminal window. And you can keep track with Git of the changes that you've made and at what state they are in the commit process. If you type git status will tell me a couple things. One is it will tell me that I'm on branch master. So we'll talk much more about branches later, but the master branch is the default branch. It's kind of the default sequence of changes that Git is currently going to keep track of. I won't say more about that at the moment until we get a little more experience with how this works. It tells me that there are no commits yet because I've only initialized the repository. And then it tells me that there are untracked files. So when we think of Git as the desk, currently I just have my files, say, on the computer. I haven't actually put them into the staging area, and I haven't put them from the staging area into the desk drawer. It also gives me a suggestion of how I might want to change that. So it tells me git add, and then file in brackets is like the file name, is the command that I can use to include any of my untracked files. And if I use git add will move them from the working area into the staging area. And then finally it tells me nothing has been added to the commit, but untracked files are present. And it tells me again about git add. The other thing that I see here in the untracked files is actually there's something here that I don't want to keep track of. This .ipynb underscore checkpoints is something that's generated by Jupyter. And this is just because I'm interacting with the Jupyter environment. You might not see something like this if you're working on your local computer. So I'm going to show you how to ignore files. You can ignore files by editing a file called .gitignore. And into the .gitignore file, you enter the files that you want to ignore, or you can enter in the directories that you want to ignore. And there are a variety of ways to include wildcard characters so that you can ignore, say, something that has a certain sequence of characters. Say you want to ignore all the object files, you can use **.o to ignore all the .o files. I won't get into that, but you can look it up if you're interested. All right, so I've said I want to ignore this particular folder, and I've specified that inside of the .gitignore file. So now when I say git status, it won't show me the .ipynb checkpoints anymore, but it'll show me that I have the .gitignore file that's also untracked. And I do want to keep a history of the changes to the .gitignore, just so that I know what it is that I'm ignoring each time I make the commit. So now I have two things that I want to move, that I want to start keeping track of. So git add.gitignore and my first chapter, chap01.txt, are the two files that I want to start tracking my changes in. So I've added them. Now they've been moved from the working area into the staging area. And if I type git status now, it will tell me now not that there are untracked changes untracked files as it did here, but there are changes that are ready to commit. And it tells me that these are completely new files. So Git doesn't have any history at the moment of storing these files. So what we can do, if we want to move the changes from the staging area actually into the repository, we use git space commit. And git commit will move them from the staging area into the repository. And then as an option, -m and something in between quotes will be a way to document the changes that I'm committing into the repository. So I'm going to type git commit, and then as my message, I'm going to say, I've started chapter 1. So usually the message that you include should be descriptive enough so that you can remember what it is that you're changing with each commit. It doesn't have to be long, but it should be descriptive. So I type this, and now Git puts out a couple of other different bits of information. So master is the name of the branch that I'm currently on. There's kind of a sequence of numbers and letters here. It tells me I've changed 2 files. And then it's kind of created mode. Mode is like the permissions mode for the files, and it's added, it tells me the particular files that it's committed. Now if I do git status, it doesn't tell me any longer that there are no commits yet because I've made a commit now. It tells me that I'm on the master branch, and it tells me that everything inside of my directory has already been committed. So there's nothing left for it to keep track of, and the working tree is clean. That just means that it there isn't anything in here that Git doesn't recognize. So now I say I come back to my chapter 1 text file, and I say, well, this is kind of not a very original sentence. I want to change it. And I say, it was a dark and stormy night. And then I save the file. So in this particular environment, I can save it on my Mac by typing Apple and S. Or you can come up to the file menu and say save file. So the file is saved. If now I come back up and look at git status, Git will recognize that the file has been modified. It no longer tells me that it's untracked because I've already committed a file called chap01.txt. But it does recognize that what I have currently saved inside of this file is different from what's actually in the repository. It tells me that this change is not staged for commit. So currently it's just in the working area. It's not in the staging area. It tells me that I can use git add to update what's been modified into the staging area. It tells me something else. So git checkout is a way to discard the changes that I've made. So we'll come back to this in a little bit. And then it tells me I can use git add, or I can use git commit -a. And git commit -a is a way, since Git is already tracking the file, it already knows to track the changes in it. Git commit -a is a way to kind of stream right past the staging, right past the git add. It kind of combines the git add and the git commit into one command. So git commit -a, and then I'll include my message. Started with dark and stormy instead. With the git commits -a, I don't have to use the git add. Git commit -a just adds it and commits it in one command. All right, so now we've made 2 commits. And in this particular one, we changed one file. It tells me that we have 1 insertion and 1 deletion. So the insertion was that I made a new sentence. The deletion was that I got rid of the original sentence that was there. All right, so coming back to this slide, I showed you git add to add files from the working area to the staging area. And I've showed you git commit will move changes from the staging area into the repository, along with a descriptive message. Git add with a period will add everything at once. And by everything, I mean, say you have tens of files that you want to add, and you don't want to have git add and then list all of the files. Sequentially, you can use git add and then the period. It's not necessarily advised in practice because if you include the period, there might be files that are added that you've forgotten about and that you don't really want to add. And by explicitly listing out all of the file names, it allows you to kind of keep closer tabs on what it is that you're actually adding. You can also commit all the changes without adding them first by using the Git Commit -A. And that's not also not necessarily advised in practice, just because, again, it's good to keep track of the different steps as you're committing changes, just so that you don't introduce additional elements that you don't realize along the way of committing them to the repository. There's a special note here for what happens with directories. So Git will track files within the directories, but not the directory itself. So what I'm going to do is I'm going to make a new directory and type git status to see what Git recognizes as the current status. And then I'll try and add the directory without creating any files inside of it. And then I'll see what Git keeps track of again. So here, by the way, here on the left, you can see all the files that are inside of my directory. So the first thing I'm going to do is I'm going to make a directory. It's called new dir. It does take Jupyter just a little while to recognize what files are there and what's not. But once it recognizes that the new directory is here, it pops up. Git doesn't recognize that there's anything to commit. So before, when I made a new file, it told me that there were untracked files. Here it's not telling me that, but I'm still going to try and add it. So I type git add new dir, and then I'm going to see what happens when I click on the status. So actually, it hasn't kept track of any changes that are here to commit. And it's not going to until I explicitly put something into new directory. Say I come into the new directory. I create just a test. I'll say that this is typing into the actual file. This is to check the what happens when using git add the files inside new directories. Well, I'll stay here inside of the new directory. So you can type git status inside of any directory, any subdirectory inside of your Git repository. It will tell me that there are untracked files. So it's not telling me yet actually what files inside of the untracked directory there are. But regardless of how many files I actually have inside of a new directory, I can add a directory in the same way that I added a file. So now when I add the new dir directory, it will tell me not that there's a new directory, but that there's a new file, which is in the new directory that I've told it to track. So you do have to be a little mindful of the way that Git keeps track of directories, only insofar as to know that it keeps track of the files inside of the directory and not necessarily open directories, and it's not going to keep track of empty directories. So just for completeness, I'm going to commit this. Right, so it changed one file. It doesn't tell me it added a directory, it tells me that it added a file. So Git is keeping track of it's keeping track of the file tree. And the file tree tells you how files are structured inside of this particular directory. And Git status again tells me now there's nothing that Git doesn't recognize. All right, so now let's consider an example. So say you've used Git to manage a file named myfile.txt. And after editing the file, which of the commands below would you want to save the edited version of the file into the repository? So I have 4 examples here. Look over them for just a minute and try and think about what your answer would be. Or you're welcome to enter it into the chat window if you want. All right, so let's go through them one at a time. Git commit -m with my recent changes is a way to commit something that's in the staging area into the repository. And we've just edited the file yet. We haven't put it into the staging area. So there's nothing in the staging area at the moment. Command number 1 will not have any effect because there's nothing in the staging area to commit. Git init myfile.txt. Well, git init is a way to initialize a repository. And we already have the repository, so we don't need to call git init. This also doesn't have the git add. Here is the correct sequence of steps. We want to add the file from the working area into the staging area, and then we call git commit to move it from the staging area into the repository, and the my recent changes is the message that gets logged. For the 4th one, git commit -m myfile.txt. This will actually give an error message because it won't know what to do with this, and furthermore, it doesn't have a git add before the commit. All right, so now I'd like you to try and do a little exercise just on your own, and you're welcome to type into the chat window if you have any questions about this. What I'd like you to try doing on your own system is to make a new Git repository, make a new file, and then commit the file to the repository. So I'll give you a couple minutes here to do that. If you have any questions, let us know. And if you aren't typing anything on the computer now, but you have a spare sheet of paper or some kind of, say, document editor, just write down the commands that you think you'd have to do to complete this. Okay, I'm going to assume that most of you are done. Unfortunately, we're not in person, so I can't really tell. But let me show you what I would do. So I'm going to make a new directory here. This is how I would approach it. We'll say the first exercise. So inside of the directory, I would initialize the repository with git init. I would make a new file then. Which I'll make pretty short. Then I would have to add new file and git commit my first commit with a message. So I'll just show you, you don't necessarily have to have the -m. If you use Git Commit, it will pop up with whatever your default editor is. So in this case, this is kind of the default editor, Emacs, which is present on Jupyter. So when it pops up with this, anything with the comments, well, it's explicitly stated here. Line starting with the # will be ignored. An empty message aborts the commit, and then I'll can type in my commit message here just on the first line. And once I save that in the editor and it returns, Git automatically carries through with the commit. There's a message in the chat window about a warning that says LF will be replaced by CRLF. I don't think that that's a problem, but you might want to consult the documentation that I mentioned earlier about the about setting this. So more information. Well, you won't have access to this until after the class, but there is more documentation that you can find about line endings. That's what the error message is respect to. There's another question: where do I specify the repository name? So in a sense, this repository doesn't have a name to it. But if you think about something like GitHub does track the name of a repository in the same sense that we're keeping track of what the name is of the folder that we're inside of. But those folder names that we're inside of don't necessarily have to match up. I could move that .git folder to a different, say, folder, and I would still have this similar information about the repository. So it's really a matter of just specifying what the folder name is that you're inside of when you're interacting with the repository. So another core thing that we want to look at is how do we actually keep track of the changes to this. And we can do this with a Git log. So I've made yes. So there's a question: how do I get a list of all the files I've committed so far? And well, let me show you what happens with Git log here first. So Git log, if we just type it by itself, since I'm inside of the directory that I just created for the purpose of the exercise, this tells me that I have I've made one commit. It only has information about one commit, which is kind of this colored line. It tells me head and master will come to in just a bit. It tells me who the author was for the commit. It was myself. So this is where your name and email information comes into play that you specify with your configuration variables. It tells me the time that the commit was made, and then it tells me the message that I gave to document my commit. If I go back to my other directory, first demo, Git log. Now I should increase this a little because I have a couple different. These are the commits that I made so far in what I was demonstrating to you. So you can see I made 4 different commits. What this long sequence is here is it's a hash code, and inside of the database, Git is keeping track of different versions of the files and identifying the particular snapshot of all of the files with this hash code. So the hash code is like an ID for each of the commits. In each of the case, I was the authors for all the commits, and it tells me the time I made the commits. Oh, I'm sorry, it starts here. And it tells me the messages that I gave with each of the commit. As far as head pointing to master, master is the default branch that we're on. So we'll talk about what branches are, but master is the particular path, the particular sequence of snapshots of files that we're keeping track of at the moment. Head is a pointer, and head can point to different ones of the commits. And this is one particular way for being able to see what the particular snapshot of the files looks like. So head is a pointer, and you can move the pointer to point at different commits. For example, if I point head to point to my very first commit, in my very first commit, I didn't have the new dir directory, and I had a different first sentence in chapter 1. So if I point head to this particular commit, what I would see inside of my folder would be the files as they existed during the state when this particular commit was made to the repository. So if I point head at different ones of these commits, I'll see the files inside of this folder as whatever state they were in as I started making changes to them. There are a couple different options you can give to Git Log. One very convenient one is to say one line. And one line is if you don't want to keep track of all this information. Usually say the first, in this case, seven alphanumeric digits. This is hexadecimal. So the first 7 of these are sufficient to identify a particular commit. It will tell me here what branch I'm on, which version head is pointing to, so I know what kind of which commit the files inside of my folder correspond to in terms of the commit history. And then it'll give me the short version of the commit log, of the commit message. There's a question, when I commit a file, it says to hit enter. When you hit enter without entering a message, it will likely take you into an editor. So in my particular case, it took me into Emacs. If you're in Emacs and you don't know how to get out of it, typing Control-X followed by Control-C will save it and exit it. I'm not sure if that particular message is what you're stuck in. If you get too stuck, just close that particular tab if you're inside of Jupyter and kind of start it up afresh. Another interesting one is to look at patch. So patch, I lost the top of it. Git log -- patch will give you a little bit more information about what it is. So in this particular way, you can start to keep track of the particular changes that were made to files during the commit. So in this case, the most recent commit, it gives me a bunch of new information, everything from here to here. And what this is a diff message. And the diff is telling me the difference between what existed in the repository before the commit and what was being added to it during the commit. So in this particular one, my commit message was made a new dir. And what the diff is telling me is for the state of the repository before the commit, there wasn't any file, which is what this dev null means. And then after the repository, the state of test.txt was it was added to the repository. It will tell me this for additional commits. So there's a lot of information being scrolled here on the screen. But this is my very In this particular commit, when I say I have started chapter 1, I added the git.gitignore file, and I added the chapter1.txt file, and this was the sentence that was in chapter 1. So git log with patch starts to tell me more about the differences that were committed. I mentioned one line. And then another useful one is graph. Graph won't have much meaning at the moment. Because you won't be able to necessarily know at the moment why this additional structure is important, but these asterisks, what Git graph does is it tries to keep track of different branches. So I'm mentioning branches, and I think perhaps now is just as good as time as any for me to jump ahead to something that I was planning on talking about a little further. So I'm jumping ahead in the slides, but what Git is actually keeping track of. The first thing that Git keeps track of is a snapshot of the files that you're interacting with. So this is a hypothetical example. But say you have one particular commit. This is part of the hash code that's generated for the commit. You have an author that's associated with the commit, and it's possible for the person who made the changes to be different from the person who committed the changes. So Git keeps track of both of them. And then you have a message associated with the commit. And what the commit points to is it points to the file tree for the files that are associated with a particular snapshot. So that the tree keeps track of, in turn, the files that are associated with the snapshot. The tree itself has its own identification number. All of the files, these things called blobs, have their own identification numbers. Say the files might have some text inside of them. They have an identification number. And this thing called a blob is a binary large object. So it's the way Git keeps track of file information. When you make commits, each commit keeps track of a particular snapshot of the state of the files that you're keeping track of. When you make subsequent commits, Git keeps track of information by, for each commit, keeping track of what the parent commit is. So the parent commit is the commit that happened before the present commit. In this case, the parent of this particular commit, which was made second, points to the identification number for the first one. The parent of the third one points to the identification number for the second. So you have different snapshots of the files. These are usually what we're most interested in. We're most interested in the files. And then there's the underlying structure that Git uses to keep track of the different snapshots. One is the identification number for the commit. And then for this entire history, the sequence of commits is on a particular path of development. The development line, you can have particular version numbers, say, so these are called tags. You can have a tag which points to a particular commit or a particular state of the files that you want to keep track of. So say you have a version 1.0, later you might have a version 1.1, 1.2, a version 2.0. You can also associate tags with a particular commit for the software. You can also have master is a pointer which points to a particular commit as well. But master points to subsequent commits as you're making your development path. So I'll talk about this shortly in a slightly different way too, so that kind of these concepts get more familiar. Head is a pointer to the branch. in this case, it's a pointer. It's not really a pointer to master, but it's a pointer to whatever state of the files it is that you're currently looking at. So I'll share this kind of graphical tool with you so that you can come and play around with this later. But this particular website allows you to play around with Git commands without necessarily having any files that you're interacting with. So say I execute Git commit. This is the first commit. When I make a commit, Git generates a new commit and it moves the location of the pointers to keep track of what the current state of the files is that I'm looking at. So if I do a couple of different Git commits, I'm not keeping track of the Git add here, by the way. I'm just saying this kind of encompasses just doing a new commit. I'll introduce branches here, but just to illustrate what happens with the branch. V2. So the way that Git handles multiple software developers, say, simultaneously editing files, is it allows them to make commits on separate development branches, and then as they develop the code, say in parallel, whenever they're ready with a particular development that they've done, they can merge their changes back into other branches of the software. We'll talk more specifically about these commands in just a bit. But what I've done for the moment is, instead of tracking along the master branch, I've started tracking along a different branch called V2. And master is actually just more or less an arbitrary name, but it's the default name to given to the branch that's created when you first do git init. But so master is just the name of a branch, just like V2 is a different name for a branch. Git checkout is a way to move where the head is pointing to. So if I was looking at the state of the files that were in my local folder when I'm doing this development, as I was making successive commits, the files inside of my folder would be changing. But when I change where head points to, the files that I see inside of my folder correspond to the particular commit that head is pointing to. So in this case, now we'll get an interactive example of this in just a bit, but the state of the files that I'll be looking at would correspond to this particular commit. If I do subsequent commits, these commits don't have to change the files in the same way that they were being changed when I was tracking the version 2 branch. But I can change the pointer of head by saying to checkout V2, and that means to change where head is pointing. I can actually move where head is pointing just by saying, specifying the identification number. So say I want to go to this particular version of the commit, and I want to look at what the state of the files were for this particular commit. I can move head to this. As you might run into when we do an interactive version of this, you don't necessarily want to detach head from where one of the branches is pointing, because it can be a little hard to keep track actually of where it is that you subsequently want head to point to. This is just to show you that you can use, you can point head at any of the previous commit ID numbers. And then I can go back to master and look at what the state of the files is for master. So when I say branch is, say, each of these development paths. And they're called branches because these diagrams end up looking like trees, and you have different branches, which should show you different development paths which are occurring simultaneously, or at least separately. All right, so we'll return to this a little later. So the idea is you have different branches when you're tracking different development paths, and you keep track of different branches or different commits that you're looking at by these pointers. In this case, there's a master branch. There's this, this is intended to be like an issue tracker. If you're tracking an issue and doing development, you might have a separate branch to make developments for an issue for code. And you might have something like a hotfix, which is just kind of a very quick fix for a bug that was found in the code. Right, so right, let's see, where was I? So rewinding a little. So I'm talking about a lot of different concepts. Let's go back to a basic one, which is looking at the difference in the files that have occurred between one commit and another. If I do git diff, at the moment git diff isn't showing me anything. And the reason it's not showing me anything is because there currently there aren't any changes that Git is saying that there are. Let me change this. So it says it was a dark and stormy night. And I couldn't see what was straight in front of me. So I've made a change to one of my files. So we're back on Git status, showing us that there's been a modification to one of the files. If I look at git diff now, it gives me information about what that modification is. So there's the version of there's the version of this file as it's stored in the repository, and the version of the file as it currently exists inside of my folder. These are what the two different chapter01.txt files are. The minus signs correspond to the version that's in the repository. The plus signs correspond to the version that's in my folder. So this tells me inside of the repository versus inside of my current folder, the change is that this particular sentence is now that sentence with one period instead of three, as well as a second sentence. So there's, you can also see what's different relative to what's inside of the staged area. At the moment, there is nothing that's inside of staged, the staged area. So git diff -- staged doesn't, there are no differences. If I add chapter01.txt, so that now these changes are not in the working area, they're in the staged area. Git diff will not tell me that there's any difference because the changes aren't in the working area, they're in the staged area. But git diff staged will tell you what's different from the repository versus the staged area. So these two commands are ways to keep track of the differences between the version of the file as it exists in the repository and the working area, or between the repository and the staged area. And you can do it for a particular file name. So if I had, say I had another chapter. on with the story into the day. Git status will actually tell me that this is an untracked file. So I can add it. There's a new file and a modified file. Git diff staged will tell me the difference between both files. So there's the chapter 01.txt file where I've changed the sentences. And there's the chapter 02.txt, which did not exist in the repository and is currently being added to the repository. And it tells me there's one new sentence in the file. I can look at just one of the files. Oops. Say by specifying what the file name is. So in this way, if there are a lot of files and you only want to know what the difference is between in a specific file, you can specify the file name and it will only generate the diff for that file name. Oops. All right, so let's get to another exercise. I've been talking about a lot, and I think it would be good for you to try and do some of this. So what I'd like you to try and do is to make a new file or files and or change the files that are in your working area for whatever repository you created. Then I want you to try and display the differences between the file's updated states and the previously committed state in your repository. And then try committing the changes and look at your version history to confirm that the changes have been committed. All right, so as far as tracking the changes, sometimes you will want to review past changes. You'll want to review old versions of files, and perhaps you might even want to recover old versions of files. I've talked about what head is. So head is the pointer to the commit that you're currently working with. And you can refer to the most recent commit in the working directory by using head in all capital letters. You can also refer to head ~n, where n is a number. And ~n will refer to the nth parent commit relative to head. So let me look at this. So first, just to remind you of what commits I've made, we can use git log --1 line to look at my commit history. So I have, yes. And I'm going to say git status just to make sure. So I do have modified files. I'm gonna commit these just so that there aren't dangling things inside of my git status. So now git status, there are no untracked changes and nothing in the staging area that's ready to commit. Git log 1 line. So head is currently pointing to a commit which includes my new chapter 02. It includes a revised chapter 1. And it's after I made the new directory. Actually, let me close these. So just to remind you of what's in the files, cat is a command which will output the content of the file to the terminal window. And similarly for chapter 2. So let's look at git diff head. Like this. So currently there isn't anything that's different because I don't have any changes in my directory that haven't been committed. Let me make some, actually. So, and this was the second day. So this is just a new line to chapter 02. So Git recognizes that the file has been modified. Git diff head will tell me the difference between what's being pointed to by head, which is the latest commit inside of the repository, and the state of the files in the current working directory. So it tells me what's being pointed to by head only includes the first sentence. Inside of the current working directory, I also have the second sentence. So there's a question, what does the @ mean? This sequence of characters, I might be speaking incorrectly about this, but it basically tells you the number of deletions, the number of insertions, and which lines were affected. So in this case, there's the first line of, say, the file in the commit, and there's the first and second line of the file as it exists in the working directory. It's something like that. I might have to look at the documentation. If I look at git diff head, say relative to the first parent, now there's actually, this tells me that there's more output than it can put on the screen. So I'm just going to increase my screen here. Git diff head ~1 is the commit that existed before what the latest commit. So in that case, now I have in my current directory, this is the state of the chapter 01 file, whereas in the commit it only had the first line with the 3 periods. And in the commit that was before the latest one, I didn't have chapter 02 text at all. So that's what this devnel tells you. And chapter 02, this gives me the complete file. So versus when I was looking at git diff head, where I had changed just one sentence in the chapter 02 file relative to the commit before the latest one, which is the head ~1, it looks like I completely created the file with 2 new sentences. So it gives me the difference in the files between, in this case, between a particular commit and the state of the files in my working directory. Instead of using git diff head or git diff head ~number, you can compare the state of the files in different commits, not just in what's in the current working directory. So if I want to compare, say, what existed in the difference between the latest commit and the parent of the latest commit, head and head ~1. In the previous commit, this was the first sentence of the file, chapter 01. And in the latest commit, it had 2 sentences in chapter 01. In the latest commit, which has the minus sign, this was the first sentence in chapter 02. This is the state of the file that currently exists in my working directory, which is different from the latest commit. And the latest commit is different from its parent. You can see in the parent, chapter 02 didn't exist at all, which is the devnel. So this is a good way to review differences between different commits. You can also look at the changes that were made in the commit with git show. So git show head, this gives you the commit message, and it's kind of like git log patch. So it gives you the diff history of the files that were committed with this particular commit, which was the latest one. So another thing that you can do is not just look at the differences between different commits, but you can revert files to a previous state. So you do this relative to head. You can do it relative to head, which points to the particular commit on the master branch in this case. You can do it with so it's a 40-digit identifier. This is the hash code, which is the identification number that Git is using for the commits. Or you can specify it with a smaller amount of initial digits. So you pick, say, 5 or 6 digits from the beginning of this, and Git will still know what it is that you're referring to as long as it's unique. So you do want to be a little careful. So git checkout head, say, will point the, it'll change what's located inside of your file folder by pointing head to a particular commit that you specify. So let me show this with an example. Say that I wanted to do git checkout head. So it tells me there's a file that's been modified, chapter02.txt. This isn't going to automatically show up in this because Jupyter isn't going to try and refresh this. But if I come up to the file menu and I reload the file from disk, it'll just ask me if I want to, and I'll say yes. Nothing's currently changed. So it's not going to try and modify the changes that I have in my working directory. Yes. So let's look at git checkout head 1. So it's going to warn me. It's going to say there are changes here that are going to be overwritten. We aren't going to go over what stashing is. If you get involved a lot with this, with reverting other changes, you will want to look up what stashing is. But so it's going to abort because that's going to try and prevent me from doing something that might be dangerous. In general, I think it's relatively safe to assume that you won't necessarily get yourself into a state where you can't retrieve changes. Git is very good about helping you to track changes and helping you to save changes. It's a good idea to add and to commit so that you have changes saved, and once you have them saved, you can be much more certain that you aren't going to lose states of the files, similar to what you might do if you mislocate a file, say, on your computer, and lose track of it or move it around and forget where it is that you placed it. The repository is very good about kind of being your own little file browser for keeping track of previous versions. So let me get back to this. I'll say I want to add the changes that I've made. So the changes are now in the staging area and they're ready to be tracked. Actually, rather than having this open, is it problematic for anyone if this cursor is much further down on the screen? I'll assume it's not. So the file is in the staging area. Let me look at what it is. By saying cat. Oops. So it has 2 sentences inside of chapter 02. And say I check out head. I still have the 2 sentences there. If I specify the file name, I tell it explicitly, I want the version of chapter 02.txt that existed in the latest commit. Now you see it's gotten rid of the second sentence, and this was the second day. And it's done that because I've told it I want to revert the version of chapter 02.txt to be what it was in the commit that head points to. Or I can even say I want the file to be like how it was in the parent to head one. In this case, it doesn't know how to do that because that file did not actually exist in head 01. So it's not actually going to try and completely delete it. But now, in this particular case, I have lost the changes that I made to chapter 02.txt because I put them in the staging area, but I didn't actually commit them to the repository. So Git reverted the file because I told it to the state that it was in this particular commit. It got rid of that. And since I hadn't committed the changes to the repository, they aren't permanently saved inside of the repository. So in this particular case, there's no way to retrieve that. Let me do, I can't remember how many commits I had. So I've had four commits. This is head, head tilde 1, head tilde 2, and head tilde 3. Let me check out head tilde 3. This is my very first commit. So it warns me that I'm in what's called detached head state. And so it says you can look around, make experimental changes, commit them, and you can discard any commits you make in this state without impacting any branches by performing another checkout. But it's going to suggest that I actually create a new branch. And this is what I showed you before, where if I have several commits, and what I've done is I've done checkout head and then some previous state, say 4. It moved me back to the first commit. I've actually detached head here means that head is not pointing to kind of what the lead branch pointer is pointing to. And here, if I look at Git Log, you'll see it looks like I have a different history completely. It looks like I only have my first commit. And if you look over here at the files that are inside of my folder, I only have the very first file that I created in my folder. That also, if I try and list the contents of my folder, the same thing shows up. And if you remember, the first sentence that I wrote was once upon a time instead of it was a dark and stormy night. The file exists in the same state it was in that first commit. This is a little dangerous being in the detached head state, because if I try and do a git checkout, my head is pointing to my first commit. There is no parent. Passback head 1 doesn't match any files known to Git. So Git checkout is useful if I know the identification number specifically, if I have different commits Git checkout with head is useful if I want to go to parents of my commit, but not if I want to go, say, to, if I want to keep on marching in this direction and into further developments. It's not easy to say git checkout head. There is no tilde with a negative. At least I don't think there is. Yeah. But if I knew the identification numbers, here I think actually, since I called clear on my terminal window, I can't scroll up to see what the identification numbers are. So I might feel a little lost. But one thing I do know is that I'm on the master branch, and the master pointer is pointing to the latest commit that I have. So if I call git checkout master, it tells me that I've switched to master. Well, that's where I was. You can see the files now are what they were in the latest commit. If I look at the contents of chapter 1, here I have the 2 sentences. And if I look at my log, the log of my changes, now I've moved head to point again back to the latest commit. So I haven't completely lost the information. The information is still stored in that .git folder. But you do have to be careful when you detach the head, that the impression you'll get when you do, say, git log, or trying to do git checkout with parents of head, the information that you see will be the information that will exist as if you're exactly in that state of the files they were in when you're in that commit that head is pointing to. Sorry, I have my top little browser thing. Come back here. So I can call git checkout with subsequent identification numbers, or I can call git checkout master to point back to the latest developments. So why you might ask, would I actually want to detach the head? Detaching the head, let me go back and do it again. I'll say git checkout 3. So it's kind of precisely for these particular reasons, which is to look around. If you want to look around at what the state is, but you don't necessarily want to use it for further paths of development, you can check out particular identification numbers for different commits, and you can be in the state of your files exactly as they were during that commit. I'll go back to master. All right, so now we're back at the beginning. I mean, back at the kind of latest stage of the commits. So coming back to git checkout, remember that these two are different commands. So if you call it on a particular file, you'll revert a file to the state it was in for a previous commit. And if the latest state of a file hasn't been officially committed to one of the commits, you do have to be worried about a little bit of changing the content. As long as the file has been committed, you can retrieve the same state. So this first one is for a particular file. Git checkout with say head, or with the alphanumeric identifier with the smaller amount of digits, will actually change the snapshot of the files that you're looking at. So here's a little question now. Say the user has made errors when editing their current version of analysis and wants to recover the last committed version of the file. which command should she use? So I have 5 options here. Take a second to think about it. So the answer is number 5. If you want to recover the last committed version of the file, you can either use git checkout head points to the latest commit, and then analysis.py is the name of the file, or you can use the unique identifier, which can also be used to identify a commit. Git checkout head ~1 will point to the parent of the latest commit, and git checkout head could potentially change the state of other files as well, because say you've edited 3 different files, it will change all 3 of them to the state that they existed in the latest commit. Here's another interactive example. So say we execute this sequence of commands. What gets printed to the screen? For those of you who don't necessarily know the syntax, this line writes Venus is beautiful to the file. This one appends this line to the same file. And cat prints out the contents of Venus to the screen. So take a second to look through it. So let's work through it. The answer is that it will only print out the first line, not both of them. Let me actually do this. So echo Venus is beautiful to Venus.text. And just to show you what's in it, cat will show us the contents. Then we add it. So now it's been moved from the staging area, from the working area into the staging area. And it's a new file. Then we want to echo a second sentence. Venus is too hot. And we append it to Venus so that the contents of Venus, now there's one line and there's the line right after it. Then we call commit. So what commit does is it moves items from the staging area into the repository. But if we look at git status, not only is there something in the staging area, there's something that's been modified that hasn't been put into the staging area yet. And that's the second sentence that we added. So if we add the second sentence, we won't be adding what is here that's been modified but hasn't been put into the staging area. So when we call git commit, comment on Venus as an unsuitable base. We changed one file, but there's only one insertion. There was only one line that was added. And if we look at git status, we added what was in the staging area, we committed that, but we didn't do anything about adding in the new sentence. So when we do git checkout head, the current state of the Venus file is here. Venus is beautiful and Venus is too hot to be suitable. That's the current state of the file. The current state of the file as it exists inside of the latest commit is only as the only with the first sentence. So when we do git checkout ed for the file, it reverts the state of venus.txt to the state that it existed as in the latest commit. We can check that here with cat. There's only the first sentence now, Venus is beautiful. And actually, if we look at git status, there's nothing, there is no modification to the file because we reverted the state of the file to how it existed in the latest commit. So in a sense, we've lost that second sentence because we committed something without remembering that we had to also add the modification that we made second. All right. So moving on, there can sometimes be files you don't want to track. I mentioned this at the very beginning. Say log files, temporary files, cached files, object files, or other files you don't want to keep track of. You can use the .git ignore file to tell Git not to track files. So in my particular case, I did include the .git ignore for the name of the directory I wanted to ignore. So now we're moving a little bit outside of just our local system. I want to talk a little bit about GitHub and show you an interaction with GitHub. So Git by itself already includes all the machinery that you need to move work between two different repositories. And as I mentioned at the beginning, Git is a distributed version control. So if you have a repository, you have a complete state of the information that's necessary for the repository. You can share, say, a folder that you have your repository in with somebody else. And that other person then would have a complete state of the repository as well. But it's usually useful to have one repository which is treated like your master copy. So services like GitHub, Bitbucket, GitLab, these are commonly used as the place where you keep a master copy of your repository. These are backed up and they're accessible through the web. So they're hosting services, and they offer, in addition to the Git services, they offer a variety of different tools to facilitate collaborating with operations that you might do related to Git. Let me open this up. I'll just show you my own repository. Here. So GitHub, this is my own repository. This is what it looks like. It will show you repositories that you have. That's kind of a central feature. Let me look at a recent repository that I made for a different class that I taught last week. So I made a repository for materials that I was using for a class for an introduction to Jupyter. So inside of this repository, there are a number of things to note. One is there are a lot of buttons and kind of things that you can click on here. Up at the top, you have different tabs. The main one is for your code, but then you can keep track of issues for software development projects. Say you might track different features that you want, fixes to different bugs. People might complain about something not working. These are kept track of in issues. And you can refer to specific files or specific commits. We'll talk about pull requests a little bit later. And then there are a variety of different ways for kind of monitoring different things about the code. But as far as the code goes, you can see there's a list of the files that I made. There's a menu which will allow you to go between different branches. At the moment, this isn't part of any software development project. I only had a master branch, and that's the default branch. But we could make different branches. We could give different tags, different version numbers, say, to the software. Beside each file, this text here is the commit message. So when I made different commits to my repository, the state of this file was last modified in a commit which had this as its commit message. So in particular, during when I updated our file badge, I put in this as the commit message, and that's when I last modified the README. You can also see the last day that the file was modified. And you can come over here to the commits, and you can look at the commit history. In this case, this is like executing the Git log in my terminal. So I have the short commit message, which is intended to be informational. This sequence of numbers tells me the hash code, which identifies each commit. And if I go over here to this button, I can browse the repository at this point in its history. So this is like the Git checkout with the particular identification number. So if I go to the very beginning, the first commit that I made, say here, I can look at the state of the files, which you can see are much different. This was something, I taught this course 2 years ago as well. So the very first commit that I made to the repository, these were the state of the files for the very first commit that I made. So just like with Git checkout, the log that I'm looking at looks a little bit different. Here it looks like I only have one commit and one branch. It tells me that I'm looking at the file tree at this particular commit identification number. But let me go back. So I can also click on the identification number, and I can see that I made one change to a file. So in this case, it was a binary file. So it's not trying to show me, well, in this case, it was a PDF file. I can click on the name of the PDF, and I can look at the PDF. I should have gone through this a little earlier to know which ones might show it. Oh, so here we go. So if you click on a particular commit, this had 19 changed files, and I can go through the negative ones are the ones that existed in the state before the commit, and the plus is the state after the commit. So here I changed 2 lines in a particular, this is a Jupyter Notebook file. In other ones, it doesn't necessarily show me the diffs because it's not necessarily decipherable in text. But I think this gives you the picture of some of the similarities between interacting with the GitHub and interacting with the command line in your Git repository. So similar to both, you have the commit messages, you have the history of the commit, you have the identification numbers for the commits. And you can check out different versions of the commits to see what the state of the files was at different points during the development. There's a question about whether people can modify the files in your public repository, or whether all they can see is what you've done, but they can't necessarily modify it. And if it's a public repository like this, yes, that's true that people cannot arbitrarily change my files. That's true. If I come up to settings, it will allow me to choose here under manage access. I have to prove that I'm myself. So I can invite collaborators. And if I invite collaborators, then I can control, say, the file permissions as to whether they can write changes into it, make commits, and exactly what it is that whether they can read or whether they can edit. You can also make a repository private if you don't want it to be visible on the public through the web. And for private repositories, you can also invite collaborators as well. So there's a lot here that you can do with the GitHub site. I'm not going to go through all of it. But I kind of touch on it to show you that there are similarities between the command lines that I've been showing you and the kind of interactive elements that you can see here on GitHub. But in addition, there are a wide range of tools and features which allow you, which kind of cultivate the environment of software development. So what I'd like you to try and do is to make a new repository on GitHub. And we'll come back to that in just a bit. So I'll walk through this. You're welcome to walk through it with me as well. I'm going to come here to my home page. So first you have to go to github.com and log in. And it might take you to something which hopefully looks like this. When you come to a page like this, I click on repositories. The repositories will list all of my repositories. So I'll see both public and private ones. Probably if I think all of these are public, probably you could probably see the same thing. Up here in the upper right, there's a new button. And when I click on new, it'll make a new, well, it'll ask me for some information about making a new repository. So I'm going to say this is my July 14. I'll say that that's my repository name. I can give it a description if I want. I'm not going to at the moment. It'll ask me if I want to make it public or private. So I'll make it public. It can ask me if I want to initialize it with a README, which I'm not going to do at the moment. And it will also ask me if I want to include the .git ignore, and I'm not going to include that either. So I'm just including the repository name, and I'm going to say create repository. So then it's created the repository, but currently there aren't any files in it. So this is kind of like running the git init that we ran before in our folders. Then it gives me information about what I can do if I want to link this with a repository that's on my computer. So it's useful to link a local copy of a repository with a repository that's sitting here on GitHub. So let's see, I'm going to make a new directory. No, actually I'm going to stay in my first directory. You're welcome to stay in your first directory as well. But if you did any of the Git exercises, try staying in that one. And I'm just going to review the command line commands here that it's telling you to do. So this first one, echo pound July 14th into README. This creates a README file which has, this is marked down for a large header. This is just to give you the name of the repository and to create a README file inside of the repository. Then inside of the folder you call git init. This just initializes the repository. Git add README moves the README file from the working area to the staging area. Git commit then commits README from the staging area into the repository. And -m first commit, this is the commit message. Then we come to something different. Git remote add origin and the web address. So what this does is it links the repository on your local computer with a repository that's sitting here in GitHub. So a remote is a way to label a repository And you can have multiple remotes that you interact with. In this particular case, the convention is just to label this particular remote with the name origin. And that's kind of a common convention that you'll see. But the remote can be named anything. So to the Git session on your local computer, this adds a remote called origin, and then it gives the web address where that remote is located. In this case, it points me to the Git repository that's sitting on GitHub. And then git push -u origin master. When I execute this on my local system, I've called commit with a README. So I have the repository existing on my local system in some state, and push is the way of transferring that commit state to a remote repository. In this case, the -u specifies that this is something called an upstream repository. So I push the commit from my local system to the remote that I've labeled origin, and I specify the branch as well that I'm pushing to. So the default branch is called master, and that's where master comes from. So actually what I'm going to do, since I'm existing inside of this folder where I already have my repository, and make sure I've committed all my changes. Okay. I've already initialized the repository. I don't have anything in my staging area. I've already committed everything. What I don't have is I don't have a remote. And you can look at your remotes just with git remote. Git remote will list all of the remote locations that you've labeled. Git remote add, and then I include the name origin, and then I include the URL for my GitHub repository. And that's specified here. If you're following along, this will likely be github.com/your username and then / the name of your repository on github.git. So when I execute this, now when I look at git remote, it tells me that my local repository is tracking a remote that's called origin. And I can be more verbose by giving it an option -v. So I mentioned push already. Push will transfer the files from my kind of local commit to the remote repository. Fetch is a way of going in reverse. So fetch will take files that have been committed to origin and transfer them back to my local repository. So this tells me the name of the remote, the location of the remote, and the fact that whenever I execute fetch or push, those are going to, by default, track with the remote called origin. And then I'm saying git push, the upstream repository is my remote called origin, and the branch is called master. And then I have to enter the username and password for my GitHub repository so that it knows that I have the right permissions to write. So it'll tell me some information, not all of which we have to know at the moment, but the most important line probably is this one. So I've transferred it from my local master branch to the remote master branch. And I've done that to the remote at this particular location. If I execute git status, now there's something new. It'll start tracking whether or not I'm up to date with a pointer that called origin/master, which is pointing to the commits as they exist on a remote repository. So I'm going to come back to my web window for my GitHub repository. And if I refresh this, it shows me the files now which are in my local repository. And not only does it show me that, it shows me the commit messages that I've made along the way of modifying these files. It tells me the modification time. It keeps track of my commit history. If I come up and look at the commits, right, these are the same as I would see if I looked at Git Log. There's comment on Venus, start a new chapter 2, make a new directory. These are all the commits that are shown here now on GitHub. So GitHub has a full version of the Git repository, which I can use now to look back at the changes that I've made in my files. So say I wanted to look at this particular commit. I can click on the name. It will tell me in this particular commit, I changed chapter 1. I changed the first sentence from once upon a time to it was a dark and stormy night. And up here, the commit stores its information about the parent, and it tells us what the hash code is for the commit. So this hash code is the same as the hash code that's labeled here. D16B9 is this the same as this one. And then the parent FA27, that's FA27, that's my first commit. Okay. So I've covered adding the remote. So I did this with, there are different protocols that you can use for transferring information. We used HTTPS. That was the one that was specified inside of inside here when we labeled the origin. It's also possible to interact with to use SSH. So I encourage you to investigate configuring that option on your own if you're interested. And then we talked about exchanging information between local repositories and the remote ones. So push transfers information from your local repository to a remote one. And pull, I didn't mention pull, but git pull will transfer information from the remote to the local. So in this case, git push origin master means that you push, say, files from your local repository to the remote one called origin, and the remote master branch of the origin. Pull tells you to pull a repository from the remote called origin into your local repository. So pull, I mentioned fetch before. If I do git remote with verbose, we have fetch and push. Fetch is related to pull, but what fetch does, fetch only retrieves the information. It doesn't try and merge it with the files that are in your repository. Pull is a way of kind of combining both fetching the information and trying to merge the information with your current files. So I'm kind of going to short circuit some of this stuff. You can edit files directly on GitHub, although I might not necessarily recommend that you do that, because you do want to make sure still that you are careful about what you specify for the adds and the commits. But I'm just going to edit this file right here in GitHub and say, this is GitHub adding text. So I can edit the file and I can commit the changes. This is committing it without adding it, but I'll just leave how it is. It says update chapter 1.text. updated the text dimension GitHub. And I'm going to commit it directly to the master branch. So I can do a commit directly on GitHub, although I've kind of bypassed the care of adding it before I committed it. So here, now I have, this is my latest commit message. It was updated 16 seconds ago. If I come to Git status, this will tell me that I'm up to date with origin master. Because your local repository isn't necessarily going to try and send out communications to repositories stored on GitHub without you explicitly mentioning that that's what you want to do. I can say git fetch. Git fetch will pull down the latest commit information from origin master. And if I look at the log, I won't necessarily see that something is different in the log, but I do see origin/master is not included here under the information in my log. Just a question to address something in the chat really quick. Oh, let me just add it here in the chat. Okay, sorry. So here you don't see origin/master labeled in the same way in the log information. I can try and check it out. It tells me that I'm in a detached head state because my head isn't pointing any longer to master. My head is pointing to new information from origin master. And I can check out the state of my files as they currently exist without changing what's in my latest commit for the master branch. So I say, well, I just have to look at the state of the files. And I can do, well, I could do a git diff. Right now, I'm just going to show you the chapter. Oops, chapter 2 changed. Or was it chapter 1? This is GitHub adding text. So I can see the change that was included with chapter 1. But I'm in the detached head state from my master branch. So I'm going to check out master again with git checkout master. And now it does recognize that my branch, the master branch, is behind what comes from GitHub, which is called origin. Origin is the remote, master is the branch, and it's behind it by one commit. It also tells me it can be fast forwarded. Fast forwarding is a way to tell you that the branch that you might want to merge in is a direct descendant of the development path that you're currently on. So it's very easy for Git to merge in the changes because it knows exactly the changes that have been made. So now instead of git fetch, I say git merge. Git merge will update the repository. It tells me it fast forwarded, and it did that by adding the sentence. The one insertion is the one line that was changed in chapter 2. I'm sorry, in chapter 1. So that sentence is in my repository, and if I do git log, now the master branch and the origin the master branch of the remote origin are both pointing to the same place. So git pull, which I mentioned here, git pull is a way of simultaneously, or I guess sequentially, but instantaneously executing git fetch and then git merge. Git fetch is the one that retrieves the information. Git merge is what combines the information from what's pulled in with what exists in the local repository. If there are conflicts, one reason it's useful to do the git fetch first is that you can actually look at what the differences are. If you execute git pull might execute the fetch, but then when it does the merge, it will let you know that there's a conflict and it'll ask you to try and resolve it before it will complete the merge. There's a question in the chat about what the git remote add command was. This is a git remote add origin, and then this is the name of the GitHub repository that you want to link with a name origin. So I'm going to type that into the chat here. And in that link, that isn't a valid link, but username and repo name are intended to be filled in depending on what your GitHub repository name is. So I already touched on these. We don't have to follow them through with an exercise. But I did show you when you go to GitHub, you can find buttons that look like the commands that we've been executing inside of the terminal. So you can track your commit history. We haven't made branches, but you can look at different branches or tags. You can see who made the latest commit. You can look at the identification numbers for the commits. This will copy in the commit identification number, and you can look at the state of the files as they existed. This is like the git checkout command that we executed. So when you're interacting with GitHub is very useful for collaboration. And the basic collaborative workflow typically goes something like this. First, if you're interacting with a repository that somebody else made, there's a command called git clone. And git clone and then the URL for the remote repository will pull in the repository to your local system. So git clone, actually I'm not sure if GitHub actually automatically tells you this, but under the code, you can get the URL for the repository under this code button. You can flip it over to use SSH, SSH protocol if you want to, but this is for HTTPS. So if I wanted to clone this repository and I didn't already have a copy of it, I would say git clone and then this URL. As you're working on the repository or as other people are updating the repository that sits on GitHub, when you first start development, the first thing you'll want to do is update your local repository with the state of the repository as it exists on GitHub. So to do that, you would do git pull. So git pull is to fetch the repository from the remote called origin and the branch called master. So if you want to fetch a different branch, you would change master to the name of the different branch. Or if on your system you have origin labeled as something different, you would change this to be the name of whatever remote you've created. But git pull will then fetch and merge the files from the remote into your local repository. Then you make your changes in your local system. and you move them from the working area to the staging area with git add. Then when you've done all of the git adds you want and are happy with your changes, you commit them to your local repository with Git Commit, and you can use the -m to specify a commit message. And then you want to upload the changes to GitHub, and you do that by pushing from your local repository to the remote. So Git Commit and Git Push are different. Git Commit, it's important to remember, only commits the changes to your local repository. Git Push is what's actually responsible for transferring the changes from your local repository to a remote repository. And then just kind of as a best practices note, it's usually to make easier to make many smaller changes rather than one massive commit, at least on your local system. This isn't necessarily the case when you're pushing to a remote one, where say you only want to push it to some master development branch, not a whole lot of time so that you don't overwhelm the history. But on your local system, it's easier to remember previous changes and to try and track and review changes if you make many smaller commits rather than one massive one, where you try and track everything at once. Maybe we probably don't have enough time to necessarily go all through this individually and then again at the end. So I recognize that it's a little tricky to coordinate exercises with pairs and for you to kind of simultaneously try and say push changes to my repository and for you to pull in changes and all this stuff. So if you want to follow along, what I'm going to do is I'm going to pretend that I'm two different people. So the first thing that I'm going to do is I'm going to clone a GitHub repository into a completely new directory. And that's going to be like part one of me. So part one of me, I'm going to make changes into the repository that I've cloned. And then I'm going to push changes back to GitHub. And then as part two of me, I'm going to pull in the changes that part one of me made into the local repository. So this might be more clear when I actually do it. So I'm going to start up a new terminal. And I'm going to put them side by side. So in this case, I'm in the first demo directory. I'm going to create another directory called local demo. And since my screens are narrow, I'm going to relabel this again. I'm going to call it part two. And I'm going to change into my my local demo directory. So there's nothing in my local demo directory, but in my first demo directory, there's the information about the repository I've been talking about. But also, so now I have something on GitHub. I'm going to pretend that I'm a new person, and I'm going to copy this into a new directory. So now I have all of the files in this. Now I'll notice it's created a folder which has the same name as the repository I've created on GitHub. This is not the same folder name as what I initialized the repository information with, which was first demo. But it does have all of the information. It has all of the information inside of the .git file folder. There's a question, what is the difference between cloning and downloading? Essentially, there is no difference. Git clone is just the command, the git command to download the repository. So now I have a version in on this particular folder, which I'm going to say, even though both of them identify as myself, I can make changes in one folder, which are different from changes that I make in another folder. So I have two copies of the repository locally, and I have one which I'm going to communicate back and forth, which is the repository on GitHub. And just so you see what happens during a conflict, I'm going to make changes in the two directories which are different. So I'm going to change the chapter 2. I'm going to say, no, I've moved into the night. So now in chapter 2, I have a second sentence in that file. In my original copy of the repository, I'm going to change this. So I have a different sentence. I'm going to say I've moved into the next day rather than into the night. So I have two copies of the repository, which now have two different versions of chapter 2. In neither of them have I added them into the staging area. So first I'm going to add them into the staging area. I have to do that in both places. And I also have to do a commit. So I'm going to say the commit message is chapter 2 night for this one. And for this one, I'm going to say the next day. All right, so now I have, this tells me I'm ahead of origin by one commit. This one is also ahead of origin by one commit, but there are different changes that have been used to advance them beyond commit. And in the GitHub repository, I still have the original, well, I have chapter 2 with only one sentence. Now I'm going to push the changes. Since I've already specified an upstream repository, I don't actually need the -u origin master. I can just say git push. So there's no problem pushing this up to origin because it was just behind by one commit. So what's on GitHub gets fast forwarded to the next commit based on what was just pushed. So if I look at chapter 2, it's chapter 2 next day. And if I look at the file, no, I've moved to the next day. That's the version of the file as it exists inside of the original. That's different from this one, which has no, I've moved into the night. So if I try and push the changes from this repository to GitHub, it's going to complain that there's a conflict. Let me pull this out so you can read what it says. So it rejected it. It said it failed to push to this remote, and it was rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same reference. You may want to first integrate the remote changes, for example, with git pull before pushing again. So it actually gives me a very good error message about what's happening. This is exactly what's happened. I pushed with this to a file that I tried to update as well with this one. So the way to resolve this is to do a git pull and then to resolve any conflicts that result from that. So what I currently have in my chapter 2, I still have the no, I moved into the night. If I do a git pull, it will transfer information, which currently exists as the chapter 2 in this folder. It'll fetch that and it will try and merge it. So it gives me information. It tried to auto-merge it, but there's a conflict because it doesn't, if it doesn't immediately think that it's easy to do the merge, it will leave it up to you to resolve the conflicts. And it tells me there was a merge conflict in chapter 2. So let's look at what happened to chapter 2. In chapter 2 now there's new information. Git, in the process of trying to do the merge, tells me that this is the information from one commit and this is the conflicting information from a different commit. In this case, there's an equal sign which separates the conflicting lines from one commit versus the other. This particular line is the one that I have in the head of the repository that I'm working with. So this is the no, I've moved into the night. That's different from this one, which currently sits on GitHub, which is no, I've moved to the next day. No, I've moved to the next day is associated with this Git commit hash code. So when interacting with the file, how you reserve the conflicts is you simply edit the file to reflect the change, to reflect how it is that you want to merge the two changes together. And then you simply add and commit the file that you've changed. In this case, I don't need the labels. I'm going to get rid of them. And I don't need the bounding line because it's straightforward to know what's different between the two. And I'm going to just, rather than including either of the lines, I'm just going to write a completely different line. Move to next year. So now I decided I didn't want to use either of the lines that were there. I wanted to use a different line. And then that file is now saved. I move to next year. I do git status tells me that there's an unmerged path. And I can mark that as resolved by adding it from the working area to the staging area. And I can commit it. All right, so let's look at what the log looks like. Well, first, git status. It tells me I'm ahead of origin, mastered by 2 commits. If I look at the log, here's one place where a graph might come in handy. So now you can start to see that Git is trying to reproduce the graphic which I was showing here. When I do Git commit, this isn't working with remotes, but say that I have a completely different branch. I'll just make this really quick. And what all I'm doing is I'm filling in commits for branches that diverge from each other. And when I try and merge in a different branch, this current commit knows that it has to point to two different commits which it's trying to merge together. So we have a development path that diverged, and then we have, say we finished on the developments on one of the branches, and we want to combine all of the development from this branch into the master branch. So we call git merge. When head is pointing to master, we call git merge and the branch name to try and merge the development that's being done on the branch v2 into the branch that we call master. And this is a common graphic to show the development path. Git log, when we say -- graph, will try and give us a similar graphic. So we updated chapter 1, and then we updated chapter 2 in 2 different repositories. So it sees that as a branching path. And then we tried to merge. We tried to push first, but we realized we couldn't push without resolving the conflicts. So we did a pull. We pulled from GitHub, and then we resolved the conflicts in our local repository. And then we resolved the conflicts and we committed them. So what it's currently pointing to is the resolution of those conflicts. And it shows that we had the 2 different paths that diverged, and when we did the merge, the paths came back together. On GitHub, we still don't have the merge because we haven't been able to successfully push from our local repository. But we have been able to do the merge successfully. So now if we do git push, the repository on GitHub is going to know how to resolve the conflicts because that's what we specified. So now the push is successful. We come back to the GitHub repository, and if I reload this, it shows that the file has changed. I've completely moved to next year. And the commit message that was responsible for this was we resolved the conflict. And we can look at the commit history. So the commit history keeps track of the fact that there were 2 different updates to chapter 2, and then there was a conflict resolution which got committed for one of the repositories. So I went a little fast through this example, but are there any questions before I make any further remarks? Okay. So in the slides, well, I talk about resolving conflicts, which I just went over. And I mentioned branching. So I fast forwarded to this near the beginning to talk about what branching is. But branching is, I think, one of the key and most powerful features of using Git. So it's a very lightweight method for being able to switch between different development paths and then merge the work together. So in terms of looking at the commits, that keep track of the snapshots of the files, and then making successive commits, which keep track of the development history and allow you, depending on what commit you're looking at, to look at different snapshots of the files. You can make different pointers to look at different commits, and you can use pointers to label where you are in different development paths. So hotfix and ISS53 are pointers to different development paths. These are different branches in the commit history. And different branches can point to different places than master, but remember that master is just a label for the default branch for your repository. So we've come to the end. So I don't think at this point it's, we won't go through the branching exercise, but I do invite you to kind of tinker around with it on your own. And I'll also send, I also invite you to kind of play around with this interactive tool. This can be helpful for playing around with the different commands and being able to move these pointers around to kind of give you a conceptual picture of what happens as you kind of branch off and try and merge things back together. Something that I didn't mention, which I do want to just touch on, is one final thing about interacting with GitHub. The common thing to do is to make a fork. And what a fork is essentially is like a Git clone into your own local folder that's sitting on GitHub. So there's, when you fork something, you make a copy of the repository, say from what's considered the master copy, which is sitting with kind of under a username that everybody who's developing the software accesses. And you have your own local repository, your own individual repositories. So on the top is GitHub. You say have one repository that you want to fork, and so you make a copy of it. And then you can clone either of these to your own local computer. It's not necessarily your problem to deal with all of the local developments for everything that contributes to the master copy, but you can push changes back and forth between your local copy of the repository and your individual copy that's sitting on GitHub. And you can pull in changes also from the master copy and make changes, say, and commit to your own local repository, and then push changes to your individual copy sitting on GitHub. And then what's typically done is that you execute a pull request. And a pull request is a request for the maintainer of the master copy to do a Git pull from your individual copy into the master copy. So that's a lingo that comes about when you think about forking and pull request. So there are some kind of best practices when you think of conflicts. Conflict resolution can cost a lot of time and effort. And it can certainly be confusing when you're interacting with GitHub for the first time. I know it took a long time for me to kind of get a grasp of exactly what's happening with Git. So I've listed some ideas here for how you can handle conflicts and how you can try and minimize them within project management. We've come to the end of the class here, so I won't talk about these any further. The last final bit of information, let me copy this just into the chat window. If you could fill out a final survey just to help us develop the courses that we're offering in IDRE and to kind of help us, help me in particular develop this course. I think We do have a survey. If you could fill it out, I'd appreciate it. I pasted it into the chat window. And you're certainly welcome at any time to email me with questions about Git or about other things as well.